Today we are going to talk about the topic of sound waves. But before we talk about sound waves, we need to learn about the longitudinal wave first. Because sound wave is a kind of longitudinal wave that travels through a medium. So far, we have studied transverse waves, which means particles move in a perpendicular direction of the wave movement. Now, let us to explore another type of waves, which called longitudinal waves. First, we need to have a skinning segment and a tape for this investigation. We will stretch this out across our desk and attach a small piece of tape on the middle of the spring. Then I will pull the coils towards this hand and I will release it. We can see the tape interferes with the pulse. The pulse of spring moves back. So we can draw a diagram like this. We have discovered in this case the particle move parallel to the movement of wave movement, which is definition of the longitudinal waves. Also, we can see that some regions of springs are compressed, and that proves a compression, but other regions of the spring are stretching out, so it proves a refraction. Those two terms are very important for this type of waves. Let us do the last interesting experiment to figure out how to represent the sound waves by looking at sound waves graphs. We need a microphone on the computer, a tuning fork, and a small hammer. I will use a small hammer to hit the tuning fork, and the computer will show a graph of sound waves. This type of graph is called pressure graph. It may have either time or position along the horizontal axis. It shows the particles' movement in low and high air pressure. So, caution, in this case, the interval of two adjacent crests here show the wavelength, not the period, because this graph shows the position, not the time of the sound waves goes in the high and low position. This is our sound wave lesson. Hope you enjoy.